Alright, we are now on the second week of Chapter 8. I believe your test on this material is next week, at least in my class. Last week we revisited the distributive property. In the distributive property we were asked to multiply the outside value by everything on the inside. Today what we're going to do is learn about the first level of factoring. Now the first test you take doesn't have a lot of factoring on it. It'll just be this type of question that we're going to learn about today and tomorrow. But that first level is important in terms of understanding factoring. In order to help you understand what factoring means, I'm going to give you a list of things that are opposite. Here we go right here. Addition. We understand that even in solving, if you want to undo addition, we subtract. If you want to undo subtraction, you add. These two are opposite enemies in terms of algebra. So again, these two go against each other at all times. Multiplication, to offset it in terms of solving. Remember, in order to offset multiplication, we divide. Also, to offset division, you multiply. Again, these two are enemies. These two are like cousins. These two are like cousins. These two are like enemies. Exponents, whenever you have the x to the second, is the opposite of square root of x. So, again, these two are opposites, or x to the third is the opposite of third root of x. But either way, those are opposites of each other, and you'll learn that in your algebra experience a little bit later. But again, that key thing is those are opposites. Remember that we went from this form to that form and from that form to this form because they are opposites. The last thing is the distributive property is the opposite of factoring, which you'll see kind of what we're talking about with that tomorrow. But again, distributive property means I start out with this answer, 3 times 2x plus 1. Factoring means I start off with this kind of answer, 6x plus 3. Notice that's your 6x plus 3. So again, whenever you distribute, you want your answer to go this way. Whenever you factor, you want to start here and end off with your answer looking that way. So again, the key thing with this is you're simply changing forms. Just like we changed from x squared to square root of x in our Chapter 7 test, we are now going to turn from this form to that form. We're going to go backwards. We're going to learn how to do distributive property, and we're going to learn how to factor, which just means going both directions on this information. Okay? I listed those opposites to just give you an idea what factoring is. If distributing is the act of multiplying the outside value, then it makes sense that factoring would be dividing because that's opposite the inside value. The process isn't difficult overall. It just takes some getting used to. The main key skills involve finding the GCF of two numbers, finding the GCF of two variables, and then rewriting the final answer. We are not going to worry about this today, but again, those two things are what we're going to look at. How do we find the GCF of two numbers? How do we find the GCF of two variables? And we're going to go from there today. So, looking at your paper again, just kind of following along, the greatest common factor is literally the largest factor that two or more numbers have in common. Largest factor two numbers have in common. So that's why I say literally, because it's actually in the name. Looking back at the words again, it should make some sense. Here are three main ways to find the GCF in terms of numbers. Some of you have good number sense. That does take practice and skill. If you do have good number sense and you always find the greatest common factor by just kind of thinking through it, that is good. Feel free to use that, but I would not just rely only on that, because if you are a number sense type of person, you want to at least practice one of these two. I would actually recommend the factor tree method or the calculator method, but I guess that's both methods, so I guess I could have just left out my opinion. Factor trees is where you just have to pretty much, as long as you know how to make a factor tree, it just takes some patience and some understanding, but again, we're going to look at that. And your calculator just takes you some programming skill that you're going to have to work on. But either way, what happens is some of you don't like this at all, so you halfway learn factor trees, then you complain you don't know how to do it, or you halfway practice the calculator method and then you really don't know how to do it. Whatever one of these two that you're going to choose, you need to make sure that you master that skill and get really good at that skill, although you do want to have both of these in your skill set. Again, whichever way you choose, I work with factor trees and calculators in these notes, mostly because those of you with number sense will incorporate the factor tree method in your head, that is. I do suggest that the number sense students learn, again, one of the other two ways, because the values will not always be small. So let's look at this real fast in terms of how we can do this in terms of each option. I will start with the factor tree method. The easiest way to do the factor tree method, and you do not need to make factor trees of both, what I would do is do the factor tree of the smallest number. So 30 being the smallest number, 1 times 30, 2 times 15, 3 times 10, 4 doesn't go, 5 times 6, 6 is already there. And what you do is you check each number. Now again, if you've got the number sense, that's great. If you don't, just grab your calculator and go down from the highest to the lowest. Check 80, because remember we want the greatest common factor. So 80 divided by 30. Oh, 80 divided by 30 doesn't work. So 30 is not it. Again, next highest number, 80 divided by 15. Doesn't work. 80 divided by 10 gives you the answer of 8. In this case, your greatest common factor is 10. So again, that's pretty much the easiest way to do it if you don't have the greatest number sense going, is to again take the smallest number, make your factor tree, and start here. The reason we don't start at 1 is because we want the greatest, and why would we start from the lowest number if we're looking for the highest? So again, you just kind of go down the list, and if nothing else is left, then your GCF ends up being 1. Alright, 24 and 28, again, take the smallest number. I'm sorry, I forgot to show you the calculator way. The calculator way was to put the smaller number on top of the bottom number in a fraction. So 30 divided by 80 equals, and then turn that into a fraction. Now keep in mind, you just did 30 over 80 equals 3/8. Now all you have to do is divide that top row. 30 divided by 3 is 10. The reason this works is because keep in mind that to reduce this fraction, you have to divide by the same number, biggest number on top and bottom, and so the calculator actually uses the GCF to turn this into that. And so again, if you like the calculator method, just be careful because it only works with 2 numbers at a time. But again, the calculator method, you're using the calculator to pretty much reduce the fraction and then identify whatever numbers it is. In this case, again, if you have number sense, you could look and say, well, 30 turned into a 3. That's obviously divided by 10, so you could use that way also. 24, 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 doesn't go, 6 is already there. Here is your list. Again, with number sense, I'm not going to use the calculator here, but you can whenever you do your practice, or you can pause it and try to find it on your own. 28 divided by 24 doesn't work. 28 divided by 12 doesn't work. 28 divided by 6, no, I'm sorry, 8, no. 28 does not divide by 6. It does divide by 4. And so my GCF in this case is 4. Alright, that is using the factor tree method. Or, again, you make a fraction with the smaller number over the bigger number and see what it reduces to be. 24 divided by 28 equals, math, enter, enter. That's 6 over 7. And then just do 24 divided by 6. And you see your GCF of 4 is what's hidden right here. Alright. 18 and 72, same thing. Take the smallest number, make your factor tree. 1 and 18, 2 and 9, 3 and 6, 4 doesn't go, 5 doesn't go, 6 is there. That is my closed list. 72 divided by 18, let's check it out because I really don't know if it divides by 18. And look at that. It gives me my answer of 4. So it gives me my answer, which means that 18 is the biggest number that divides into both, because 18 divides into 18. 18 also divides into 72. Again, the other way to do that is to put 18 over 72 and see what you get, which is 1/4. And then again, take top numbers and divide. 18 divided by 1, which is 18, and again you see that you get the same GCF. Now if you simply let me go through that and did not use your calculator or did not write anything down on paper, please don't be frustrated when you don't know what the heck is going on, because you have to practice that stuff in order to get it down. So even if you have to pause the video and go through whatever process you feel like you're going to be strongest at, you have to practice that skill. Same thing on this. Find the GCF of each set of numbers. If there is no calculator method for this, so again you're going to have to make sure you get it down this way. Looking at 20, 24, and 40. Again, what I'm going to do is pick the smallest number, which is 20. 1 and 20, 2 and 10, 3, nope, 4 and 5. Once it doesn't go into 1, it can't go into any of them. 20 does not go into 24, so 20 can't be it. 10 does not go into 24, so 10 cannot be it. I understand 20 goes into 40 and 10 goes into 40, but you want the GCF of all of them, and since 20 cannot go into 24, those are done. 5 might go into 40, but it does not go into 24. Nope. 4 goes into 24. It also goes into 40. In this case, your biggest number is 4. But again, notice it's just using the same thing. And again, the number sense people kind of think about this highest number to lowest number in your heads, and you ask yourself, can 20 go into these numbers? Nope. Next number would be 10. Next number is 5, and just kind of work your way down, because that's honestly just the way you do it there. All right. 16, 72, and 24. So we look at 16. 1 times 16, 2 times 8, 4 times 4. I know for a fact that 16 does not go into 24. 8 goes into 24. I believe 8 also goes into 72. Yes, it does, which means that the number that works in this is 8. Alright, so that is again how you find the GCF of sets of numbers, either using the calculator or using the factor trees. Next part is find the GCF of two variables. In order to understand the process of finding the GCF of two variables, we have to first make sure you remember what part exponents play in the image of the variable in terms of what it looks like. For example, we know that x to the third means it's 3x's being multiplied. We know that x to the seventh is 1, 2, 3, 4, 5, 6, 7 x's being multiplied. So if we were being asked to find the GCF of x to the third and x to the seventh, the problem is just asking us to identify how many factors. Remember that factors are the numbers that multiply, so these are all factors of x to the third, these are all factors of x to the seventh, and they want to know how many they have in common. So looking back, this is all you do. These two sets of factors have 1, 2, 3 x's in common, and that's it. So your GCF of that would be x to the third. That's all. So again, knowing that this is 3 x's, knowing that that's 7 x's, how many do they have in common? They both share 3 x's. Alright? Now consider the following variable terms. C to the 6, which is 6 c's, c to the second, which is 2 c's. How many factors do these have in common? Common sense, and I think just basic observation means that they both have 2 c's in common. And that would be the GCF of c to the 6th and c to the second. Notice that in both situations we could have simply chose a smaller number. Again, that's the shortcut. It's not really a shortcut. I put that word in parentheses because a shortcut is actually whenever you can do the same work in your head out of analysis. If you understand what the variables look like, then you understand what you're looking for. So for example, if I asked you to find the GCF of x to the 7th and x to the 5th, we understand that has 7 x's. We understand this has 5 x's. How many do they have in common? Well, obviously the answer is 5 x's. So you'd be able to just kind of find that quickly without having to think too much. Alright? So again, that is the general idea of doing the variable part. So where we're going to stop today is just to find the GCF of an expression. But in order to do that, we have to consider the GCF of numbers and variables separately and then write them as one term. So work through these examples with me and then get ready to go ahead and get your practice on your own. Again, each part separately. 6 and 10. If you don't know what it is, just do your GCF for 6 or your factor tree for 6, 1 and 6, 2 and 3. 6 doesn't go into 10, 3 doesn't go into 10, 2 goes into 10. Now here's where you have to be careful. This has 1x. This has 0 x's, which means that what they have in common is none. That means that your GCF in this is just 2. There are no variables that they have in common, otherwise there would be a variable over here. Again, this has an x, this does not. Your GCF in this case is just 2 because 2 goes into both numbers. That's as far as you can go. Looking at this one, 14. 1 times 14, 2 times 7. 14 doesn't go into 35, but 7 does, so write down your 7. Now in terms of your variable, you've got 2 x's here, 1 x there. How many do they have in common? Well, the answer to that is 1. Again, remember that's 2 x's, that's 1 x. We simply take the smaller amount, so the smaller amount in this case is x. So your GCF of the full expression is 7 because of 14 and 35, and x because of x squared and x. That's all you have to do. Again, it's going to take some practice, but it's not that bad. After a while, you don't even need to make so many of factor trees. You just go ahead and go straight to it. 25 and 10. Again, making the factor tree for 10. 10 doesn't go into 25, 5 does, so my biggest number is 5. And the number of variables I'm going to take is the lowest amount, which is x to the third. So my GCF for this full expression is just 5x to the third. Looking at the next one, 6, 12, and 9. Again, pick the smallest number, 6 if you have to. 3 goes into 12, I'm sorry, 6 goes into 12, but it does not go into 9. 3 goes into both, which means my biggest number is 3. In terms of variables, again, choosing the smallest, this has 3 x's, this has 2 x's, this is just a regular x. So we choose the x because that is the smallest, that is the winner, or the one that they have in common, and that is it. Alright. Looking at E, 16, 20, and 8. Think about the factors for 8. Does 8 go into 16? Yes. Does 8 go into 20? Nope. So that's done. Does 4 go into 16? Yes. Does 4 go into 20? Yes. So my biggest number is 4. But in terms of factors of m, the lowest number here is m squared, so they all have 2 in common. Again, the first one has 4 m's, the second one has 3 m's, the last one has 2 m's, which means that all these have 2 m's in common, so that's why we use the m squared. And then the last example, again, make sure you're writing these down as you get, or as you see them. Pause the video if necessary. Looking at the factors of 8, pay attention to this because this is one situation that pops up sometimes also with numbers. 8 does not go into 9. 4 does not go into 9. 2 does not go into 9, which means your greatest common factor is 1. Now we only write the 1 if there's nothing else that comes out. So we'll hold that, and if nothing else comes out, we'll put 1. But again, in this case, we need to check out our x's. Well, notice you've got 7 x's over here, 1 x over there, which means that my GCF for x's is just 1x. But we also have y's. We've got 3 y's here, 5 y's there, which means that I again choose the smallest. That represents your GCF for that. Again, this one here had 7 x's, 1, 2, 3, 4, 5, 6, 7, and 3 y's. The second one had 1x and 5 y's. And what they have in common is 1x and 3 y's. And that is where you get your x. Y to the third is your answer there. Alright. The rest of the day is set for you to practice finding the GCF. You should also take some time to practice some of the material from last week. Outside of that, this skill is best learned by experience because the more mistakes you make, the better you'll eventually be. Before moving on to the work, please answer the following question from the notes. So for your lesson credit, find the GCF of this, bring it up to me so I can give you some feedback on what you did right or what you did wrong. And outside of that, after that, you can go to your Math Excel or do whatever you need to do in your class. Good luck today.